In this video, we're going to be working through the May-June 2024 paper 13 question 3 problem. And again, right, so before we even look at the question, you flip through your exam and you see this diagram, right? One of the first things you're going to see is going to be theta radians. So you stop, right? So you're going to stop, make sure your calculator is set to radians and not degrees or any other angle setting, right? And the moment you do that, you also then see, okay, I can see arcs, I can see circles. So this is probably a circular measure problem, right? So now let's read the question. Actually, no, before we read the question, we can see that we have a center C, we have radius R, this angle that goes on the outside, right? So this angle, which is greater than 180 degrees, is theta radians, right? And then we have point A, point B, which are both on the circumference. All right, but now let's read the actual question. Right, the question says, the diagram shows a sector of a circle with center C. The radii CA and CB each have a length of r centimeters, and the size of the reflex angle ACB, right? So this angle over here is theta radians. So remember, we're looking at the side. Because it's reflex, it has to be the side that is, greater than 180. Should be between, less than 270 as well. Right. The sector, shaded region, shaded in the diagram, sorry, has perimeter of 65. Right. So that's interesting. Perimeter 65. Let's just make this a little bit thicker. Right. Perimeter is equal to 65. And the area is 225 centimeters squared. All right, perfect. Find the values of r and theta. Okay, so they haven't given us too much information, but the key pieces of information we have highlighted, which are perimeter and area. So let's start there. Okay, so how do you find the perimeter of a shape such as this? In order for us to find the perimeter, essentially what we want to do is we want to say, okay, add up all of the sides that make up the shape. So the sides, if we're starting off at point C, going down to point A, that's going to be R, plus we have the arc AB, right? So we have arc length AB, and then from B back to C is going to be another R. Okay, so just to then see what we don't have, because remember, we don't have our R, right? We do have the perimeter though, which is 65, right? So we can plug that in. We don't have R, but that's perfectly fine. That's one of the things that we're trying to look for, right? We're looking for the arc as well, right? Now the arc length AB, in order for you to find the arc length of a circle, right? S is going to be equal to the radius multiplied by the theta, right? So the angle around that arc. So that's going to be R times theta. And again, we don't know R, we don't know theta, but that's perfectly fine, right? And then we also have this radius over here. The good thing in this case is we have worked everything out until a point where the only things that we have left in the formula are the unknowns. But we can actually simplify this a little bit further, right? So maybe let's write it as 65 is equal to R plus R gives you 2R plus R theta, right? And we also have the option of just making sure we have one R in our equation and one theta in our equation by factoring out an R. So that becomes 2 plus theta. Okay, so this might be useful, it may not be. Maybe we might need to just work it out in this format, but we'll just write it in this format just in case, right? Just in case it ends up being helpful. Okay, so that's perimeter, right? So perimeter was quite helpful. So maybe let's now go to area, right? How do you find the area of an arc? The area of an arc, just like with this, we have a formula, right? The area of an arc is, or at least of a sector, is half r squared multiplied by theta. All right. Now remember, we're working on this angle over here, right? So just because it's not this angle, because that angle would then if you plug into this formula, it will give you a smaller area. But we're working with theta, the theta that we've been given. And essentially, we've been told that the area, actually, let's just go back here. This is half r squared theta. We've been told that the answer for this, the area, is 225. We don't know what r is. We don't know what theta is. All right, so maybe let's isolate these. So if I multiply both sides by 2, it's going to cancel this half over here, right? Or if you want to write it as 2 over 1, it's going to cancel this half on this side, but it means we need to multiply this side by 2 as well. 2 times 225 is 450. I hope I didn't make a mistake there. That's equal to r squared, theta. Right. Maybe we want to simplify this to the point where we say theta is equal to, or at least divide both sides by r squared. Right, so r squared is going to divide over here, but that means our answer is going to be theta is equal to 450 over r squared. This, I'm trying to see which is the most helpful format to work this in. Okay, you know what? Any route you take at this point is going to be correct, right? Because remember, we have two equations, right? So we've got the equation that we came up with when we were using perimeter, the equation that came from area, right? So now, if it's two equations and two unknowns, you have to use simultaneous equations. And since we have a squared, it's a matter of plugging and playing, right? So this is going to turn into a whole quadratic equation and so on. So whatever route you decide to take here, whether you want to isolate this r, put that r into this equation, or you want to do what I'm about to do where I isolate this theta and then I put that theta into here, whichever route you take, you should come up to the same answer. So what I'm actually going to do here is I am going to take this and I'm going to move it up here. All right. Let's just create a divider over here. Just to show, okay, just to show that these were different. All right. So now this equation is actually going to turn into 65 is equal to r multiplied by 2 plus, but instead of having theta, I'm going to substitute this expression over here. So that's going to be your 450 divided by r squared. Okay, so now this is progress because now we just have a formula that just contains r's. So, right, so actually maybe I should have used this format because now I want to multiply the r's back in. That's going to be 2r plus r times this gives you 450 r divided by r squared. That gives you 65. Okay, so we have this r on top and we have one of these r's is going to cancel with one of those r's. So that gives you 65 is equal to 2r plus 450 over r. Now, we don't like unknown values as denominators in our equations. So what we're going to do is we're going to multiply each of these values by r. It's going to cancel over here, so we don't have a denominator anymore. But remember, what you do to one expression, you have to do to the whole thing. So that's going to turn into 65r is equal to 2r squared plus 450. And this is a quadratic equation because we have a squared expression, an r expression, and a constant. So this is a quadratic equation. So I have run out of space completely here. In the quadratic equation, we need to make sure we have everything on one side. So this 65r has to come to this side. So this is going to turn into 2r squared. I almost made a mistake. I almost made that plus. But remember, it was plus on this side. When it crosses over the equal sign, it becomes minus 65r plus 450, right? And at this stage, I like to go traditional, right? Traditional tells me that I need the a for this equation, which is the constant on the r squared expression, which is 2. I need the b, which is negative 65. I need the c, which is positive 450. So coming back up here, switch back to black. R is equal to, now we use the quadratic formula. Quadratic formula says it's negative b plus minus the square root. Maybe let me just not use black here. Quadratic formula says, maybe I'm going to write it here. R is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. Okay, so now we just need to plug and play. Our b is negative 65, which means this is going to become negative 65, which then turns into positive 65. Plus minus the square root of b squared, which is negative 65 squared, minus 4 times a. The a value in this case is 2, times C, which is 450. All of this is going to be over 2 times A, which is 2 times 2. Okay, so at this point, I'm going to throw it into my calculator. But remember, because we have this plus or minus sign, right? It means we need to work this out for when that's in the equation, when that's positive, and we also need to work it out for when it's negative. All right, so I'm just throwing it into my calculator here. If you can hear some silence in the background or some typing, divided by 4, this gives us 22.5. That's actually a very good number. So the radius is equal to 22.5. However, remember, a quadratic equation is always going to give you 2 answers. So we now need to, if you use the same route that I did, I now need to make sure that that answer is negative to see what the second problem is going to be. The second answer is going to be, it's 10. Okay, so the radius is going to be 10. We don't actually know which of these is going to give us the correct answer because we haven't been given any restrictions like, radius must be greater than 15 or something. But maybe what we can do is we can then come here and say, okay, I have 2 answers of radius. Each of these is going to give me a specific answer of theta. Remember, theta is equal to 450 divided by r squared. So we're going to say 450 divided by 22.5 squared. That's going to give us an answer of 0.8. Say how many significant figures? No, they did not. So 0.889 basically radians. Now 0.889, right? What answer is that? Could that be the right answer, right? So remember, our answer has to be greater than, because the reflex angle, it has to be greater than 180 degrees. 180 degrees is pi. If you put pi into your calculator, it's going to be 3.14. So our answer has to be greater than 3.14. This means that this answer cannot be correct. Okay, now let's work on the next one, right? Because maybe both of them are wrong even. Theta is equal to 450 divided by 10 squared. That's 450 divided by 100. That's 4.5. Actually, we don't need to put that into our calculators. 4.5 radians. Now 4.5 radians, does that make sense? Yes, it does, because that's greater. 4.5 radians is greater than 3.14, right? But it's also, because remember, it also has to be less than 270, I think. So 270 is 3 pi over 2, which is, if you put that into your calculator, that's 4.71. So that kind of makes sense. It's falling into the region that we estimated it would be. So it means that our answers have to be, so I'm going to take this, maybe put this over there on the side. Okay. Therefore, our answers are radius is equal to 10, because this is the one that worked, and theta is equal to 4.5 radians. This is 10 centimeters. These are the 2 answers. Okay, that was a lot of work for 4 marks. But as long as you get to the answer, then it is perfectly fine. Right, okay. Now, the next question, which is a 2-mark question, is maybe, hopefully, this one isn't going to be as much work. Find the area of the triangle ACB. Now, what is the triangle ACB? So we don't see a triangle over here, right? So maybe let's just remove these. We don't really see a triangle in our diagram, but they're assuming that we are going to connect the fact that we have this line, A to C, we have C to B, and the thing that's going to connect the triangle is going to be this over here, right? So we have that triangle basically. So we can do this in one of 2 ways, right? So the first one is going to be, we can use half base times height. That's going to be tricky because it's going to have us working on, trig and all of that stuff. However, what we can do is we can use the area rule. The area rule says, if I have this side over here and I have this side over there, right? If I have 2 sides that come together to connect and give us an angle, right? So these 2 lines are coming together to make this angle. We'll call this theta, or in fact, we'll call this C, actually. The area rule says the area of that triangle is half A times B. It's actually small a, small b multiplied by sine C. where for this triangle, this is going to be point line A, this is going to be line B, and this is going to be point C. So in order for us to find the area of a triangle, all we need are two lines that come together to make an angle. So we need the lengths of those two lines and the angle that those two lines create. So now the question is, do we have those, right? Yes, we do, because for this triangle, let's just redraw this actually. We know that we have this R, which is 10. We have this line, which is 10. And then we have this angle over here. Now that angle is tricky because we actually don't know what it is specifically, but we do know what this other outside angle is. That outside angle is 4.5 radians. And we also know that the area of the angle on a full circle is 360, which is 2 pi. So this one is actually 2 pi minus the angle that we got before, which was 4.5. So that means we have everything we need. So coming back to the problem, the area is half AB sine C, which is half of your first line that makes the that creates, let me just take this and bring it to the question that we're actually working on. That didn't work. Okay. All right. Maybe let's just put that here because I don't think we're going to need a lot of the space. Okay. So we have half A, B. The two lines are going to be 10 and 10, right? So that's half of 10 times 10, which is 10 squared. And then sine of C, which is 2 pi minus 4.5 radians. Again, make sure that your calculator's in radians before we enter this. So that's going to be half of 10 squared, which is 100 over 2, which is 50, multiplied by sine of 2 pi, let's put brackets there, 2 pi minus 4.5. So your answer is actually, the area is 48.9 centimeters squared. This is in centimeters, right? Centimeters, yeah. Okay, centimeters squared, perfect. Nice. So that one wasn't too bad, right? Unless you had gone the route of, trigonometry and all of that stuff. But yeah, let me stop the video right there. So I hope this wasn't too confusing, right? But again, always just give me feedback. I can always just make corrections and make new videos. But I hope this was helpful. And as always, I will see you in the next video.